Welcome back, friends. Today we are going to discuss about the behavior of non-ideal solution of positive deviation on distillation. In the previous session, we discussed about the introduction, about the behavior of non-ideal solution on distillation, and we introduced the concept of isotropic mixture, that it is the constant boiling point mixture whose composition does not change on distillation. So today we are going to continue, and for the sake of today, we are going to look for the case of non-ideal solution of positive deviation from Roots law. Now, how does this solution behaves in the Roots law? If you viewed my previous session, we said that the non-ideal solution of positive deviation from Roots law tend to form the isotropic mixture having the boiling point which is less than the boiling point of the two pure liquids. So we are saying that non-ideal solution with positive deviation boils in such a way that the vapor formed during distillation attains isotropic composition, lakini inafikia isotropic composition ambayo hiyo isotropic composition itakuwaje? During distillation, what is corrected as residue or distillate depends in the composition of the solution, and not in the volatility of the components of the solution like ideal solution. Now again, I bring you back in the distillation of ideal solution. If you remember this graph, which I explained it in the previous session and in many previous sessions about the behavior of ideal solution on distillation. And we said that if we distillate this solution at point, let's say at point Q, we'll get a vapor at point R, which when condensed, we will get a solution at point S, which when we evaporate again S, then we get vapor at point T. Then if we condense this, we get a liquid at point U. Evaporation, successive evaporation, condensation, evaporation, condensation. Finally, we get the distillate and the residue. Now, unachoweza ukakiona hapa ni kwamba hapa kabisa inajulikana kwamba distillate wetu lazima awe nani? A. Kwa nini? Kwa sababu A is more volatile. Wakati residue lazima awe nani? B. Kwa nini? Kwa sababu B ni less volatile. Sasa in these cases tunajua kabisa distillate atakuwa nani? Residue atakuwa nani? So here, what will be the distillate and what will be the residue depends on the volatility of the liquids. Depends on the volatility. Which one is more volatile? But in the non-ideal solution, the story changes, because which one will be the distillate and which one will be the residue does not depend on the volatility again, but depends on the composition of the solution which we are distillating. What is the composition of the solution which we are starting distillation? So during distillation, what is corrected as residue or distillate depends on the composition of solution and not in the volatility of the components of the solution like ideal solution. We'll explain this in detail in this session and you will understand what we're talking about. Now we are saying that the vapor formed must attain isotropic composition, and hence the distillate which is formed in the collector must be isotropic mixture. Regardless on the volatility of the solution composition. So tunajua kwamba the components of the solution lazima zitakuwa zina different volatility. Some of them will be more volatile as compared with the other. But finally we must form an isotropic mixture. So tuta evaporate, lakini baadaye tutafikia isotropic mixture ambayo isotropic mixture kama ikiwa ni vapor, tukicondense tutapata isotropic mixture ambayo ni nani? Ni liquid. So as I started before, that non-ideal solution of positive deviation from Roots law has a boiling point less than either of the component liquids. We have already explained this and we draw the graph in the previous session that the non-ideal solution of positive deviation, they have the boiling point which is less than the boiling point of the either of the two pure liquids. Now let's move to discuss about the boiling point composition curve for non-ideal solution of positive deviation. Boiling point composition curve for non-ideal solution of positive deviation. So for the case of non-ideal solution of positive deviation, this is the boiling point composition curve, na kama ambavyo unaweza kuona huku juu tunazo boiling point, na kutoka hapo tuna temperature B, tuna temperature A, tuna vapor phase, tuna liquid phase. So vapor phase, liquid phase, temperature of B, temperature of A. This is temperature of isotropic mixture. Temperature of isotropic mixture, or sometimes you call it the isotropic point. Hii temperature. Asa hii temperature kuchukulia huku au kuchukulia kwenye ile hii. But here is where we are saying it is formed the isotropic mixture. So huku ni liquid phase, huku ni vapor phase. Sasa huku chini kama unavyoona tuna mole fraction kama kawaida. Liquid A imeanzia huku liquid A, huku liquid B. So the mole fraction of liquid A itaanzia ku 0 itaenda hadi 1. Mole fraction of liquid B itaanzia 0 itaenda hadi ku 1. Hii hapa tunaita isotropic composition. Kwa hiyo hapa ni isotropic composition, hii hapa ni isotropic mixture, hii hapa ni isotropic point. Wakati huku tuna boiling point of the pure liquids. Kwa hiyo kwenye positive deviation kama ambavyo unaweza kaona kwamba boiling point of B iko hapa, boiling point of A iko hapa, lakini the boiling point of the isotropic mixture ni hapa, which is lower as compared with the boiling point of the pure liquids. Kwa hiyo kwenye hii case boiling point ya A ni ndogo kuliko boiling point ya B. In other words, A is more volatile than B. But the composition of the isotropic mixture, kama tulivyosema, composition of isotropic mixture does not depend on the volatility, but it depends on the composition of the solution ambayo tuko tunaifanyia distillation up, the composition of the solution. So from this graph we are saying whereby T8 the boiling point of pure liquid A, TB the boiling point of pure liquid B, and T small a the isotropic point, X8 the mole fraction of liquid A, and XB the mole fraction of liquid B. Now let's see an example. By discussing using example, it will be very easier to be understood each other and to discuss what will happen on distillation. So let's see an example. Consider a mixture of ethanol and water. A mixture of ethanol and water. So if we are considering the mixture of ethanol and water, which form non-ideal solution of positive deviation. Ethanol boils at 78 degrees centigrade, and the water boils at 100 degrees centigrade, and their solution form isotropic mixture. When ethanol is 96%, the boiling point of mixture is 72.2 degrees Celsius. So kwenye swali unaweza kuambiwa labda uchole graph ya hiyo. Ni very easy, haihitaji kucompletisha na hatutumii graph paper hapa, tunatumia tu karatasi ya kawaida. Kwanza unatakiwa angalia mixture of ethanol and water. Form non-ideal solution of positive deviation. Ethanol ina boil pale, water na boil. So boiling point ya water ni kubwa kuliko ya nani? Ya ethanol. So tutakachokifanya tutachora graph yetu. Nitakuonyesha tu graph hapa. Graph ya kwenye notes nitakuonyesha. Ila nataka nikuonyeshe ili kwamba kama kwenye exam ukiambiwa uchore a graph of non-ideal solution ya aina hiyo hapo unachoraje. So tunachora hapo. Taka tu illustrate graph. So this is the boiling point, and this is the boiling point. Unaona? From there sasa boiling point ya water tumeambia ni ngapi? Ni 100. 100 kwa naweza nikaleti 100. Let's say we pale 100 degrees Celsius. So hii side nitaweka water, maana nimeshaweka boiling point yake. Toka hapo kwingine nitaweka nini? Ethanol. So nitaweka ethanol. Ambapo ethanol nimeambiwa boiling point yake ni ngapi? 78 degrees Celsius. So nitaweka ameni 178, naweza nika approximate maybe somewhere there. So 78 degree. Hapo hahitaji graph paper. And then we are told isotropic mixture inatengenezwa wakati ethanol ikiwa asilimia ngapi? 96. Hasa remember, unaweza kuona hapo kwamba ethanol, mole fraction of ethanol huku inaanzia 0, huku inakuwa 1. Hii ni mole fraction of nini? Of ethanol. Wakati mole fraction of water huku inaanzia 0, mole fraction of water huku inaanzia 0, inafika mpaka huku ngapi? 1. So tunavyokuambia asilimia 96 nani? Ya ethanol. lazima graph yako hiyo ina point of nini? Reality. 96% maana yake ni kama 9.6. Kwa bila shaka itakuwa ni very close to this side. Ethano iko nyingi. Lakini from there tumeambiwa boiling point ya nini? Boiling point ya isotropic mixture ni 72.2. So tunaweza tukalete labda point fulani pale iwe ndio 72 point ngapi? 72.2 centigrade. Unaona, tukishaleti hapo maana yake hapo ndio itakuwa. So from there hii composition isotropic mixture itakuwa pale. So hapa tutachora tap mpaka this point, ambao hii point itakuwa straight to the isotropic composition. Lakini from here tutachora another line mpaka wapi? Kwenye water pale. Unaona? And then from there hii hapa tutachora tap, and hii hapa tutachora kama hivi. So tutalebo tu huku ni vapor phase. Huku tutalebo kama nini? Liquid phase. Hapa tunaweza tukalebo isotropic mixture. Na hapa tunaweza tukalebo kuwa ni isotropic composition. Isotropic composition. Kwa hiyo ninachokizungumza ni nini? Kwamba unaweza kukutana na swali kama hili kwenye mtihani ukaambiwa uchore graph, ukapewa information kama hizo ukaambiwa uchore graph. It is very easy. Naenda kuona graph sasa iliyoko kwenye notes ipoje. Tutaelezea vitu mbalimbali kuhusu hiyo isotropic mixture inakuaje. So kuhusu hiyo graph ya isotropic mixture hapo inakuwa inaonekana kama hivyo. Unaweza kuona hii ndio diagram yetu, na difference kati ya hii diagram na ile tuliyochora ndogo tu. Hii diagram yetu ilikuwa imeangalia upande wa huku, lakini diagram hii imeangalia upande wa huku. Lakini kitu kile kile, angalia 100 degrees Celsius 100 degrees Celsius iko juu, inafuata hapa chini 78 72.2. So everything viko pale, viko labeled. Now tunachotaka kuelezea kwenye grafu ni jinsi gani ambavyo hii solution itabehave. Tunachotaka kuelezea jinsi gani solution itabehave. Sasa unaweza kuona kwamba tukiwa tuna liquid hii hapa ina composition fulani hapa. Let's call this concentration as C1. Tukiboil, tukacondense, tukaboil, tukacondense, tukaboil, tunakuja kupata nani? Isotropic mixture. Lakini pia hata kama ungeanza na liquid ambayo iko huko, tungeboil, tungecondense, tungeboil, tungecondense, tungeboil, tunakuja kupata isotropic mixture. So from either side we will start either kule ambako ethanol is rich au kule ambako water is rich. From either side mwisho wa siku utakuja ku end up with isotropic mixture. You will end up with isotropic mixture. Kwa hiyo whether umeanza na solution ambayo water imezidi au umeanza na solution ambayo ethanol imezidi, kokote ulikoanzia utaishia hapo kwenye isotropic mixture. Sasa one among the very difficult part to be understood in states of matter ni hiki kipengele. Ni kigumu sana watu wengi kukielewa. So I hope if you stay tuned utanielewa kile ninachokimaanisha. Hasa basi tunaangalia kwamba je, tukianza na solution ambayo iko upande huu of isotropic of solution iko upande huu, yani it is richer in water, what will happen at the final isotropic mixture? What will be the residue and what will be the distillate? Na tukianza na solution ambayo iko upande huu, what will be the residue and the distillate? Kwa upande huu ni solution na upande huu ni nini? Ni solution. Tunaangalia kwamba solution ikiwa rich in water tutapata residue nini, na solution ikiwa rich in ethanol tutapata residue nini. Tunaweza kusema ni kwamba from the graph, if you distill a mixture of ethanol and water with the composition C1, if you are looking at the composition C1, it is rich in water. Unaona, with composition C1 as shown above, it will boil at temperature T1. Unaona, composition C1 itaboil temperature T1. Lakini ukiboil utapata vapor pale. Ukicondense ile vapor itaboil kwenye different temperature, slightly lower temperature which is T2. Unaona? So in T2 hapa composition of ethanol itakuwa imeongezeka while composition of water imepungua. So concentration hii hapa C2 ambayo inaboil at temperature T2 yenyewe inakuwa na composition ya ethanol iliyoongezeka as compared to that of water. So maana yake hapo kinachokuwepo ni nini? Ethanol inakuwa inaongezeka and pure water is left residue. Unaona? Lakini at the end of the day we will get isotropic mixture. We can't get pure water and pure ethanol. So we can get pure water as the residue, but we can't get pure ethanol as the distillate because of the formation of isotropic mixture. Kwa kinachokuwa kinafanyika ni kwamba kile kitu kilichozidi ndio kinakuwa kinapungua. Kilichozidi kinakuwa kinafanyaje? Kinapungua mpaka tunafikia isotropic mixture. Hasa tuone kwamba tukidistill your solution at concentration C1 as shown above, it will boil at temperature T1. It will boil at temperature T1. Lakini and produce a vapor with composition C2 rich in ethanol. So tunapofika kwenye composition C2, amount of ethanol inakuwa imeongezeka. Tukianzia hapo unaona hapa water composition yake ni kubwa kwa sababu hapa water ndo 100 wakati huku water ni 0. Kwa tunavyozidi kwenda hivi composition of ethanol inafanya ina increase. Tunavyoenda hivi composition of water ina increase. So moving from C1 to C2, the composition of ethanol in the solution has been increased and the composition of water imepungua. Kwa hiyo ile iliyopungua imeenda wapi? Imekuwa residue. So tunasema kwamba when that vapor condenses, it will also have the composition C2. But if you reboil the condensed vapor, it will produce new vapor with composition C3. Kwa ukiboil vapor ya kwenye C2, ukiboil vapor ya kwenye C2, utapata vapor ambayo ni ya kwenye C3 yule pale. So vapor ya kwenye C2 ukiboil unapata vapor ambayo yuko kwenye composition C3. Sasa tunasema kwamba on successive distillation and condensation, what will happen? On successive distillation and condensation, you will end up with composition of 96 ethanol, which is isotropic composition. 96 ethanol, which is isotropic composition. Kwa hiyo sasa tunachozungumza nini? Tunataka kuona which one will be the distillate and which one will be the residue under these circumstances. Which one will be the distillate and which one will be the residue. Hiyo ndo very important concept kwa wewe kufahamu kuhusu distillate pamoja na residue wa hiyo solution yako atakuwa ni nani. Sasa basi tunasema kwamba yule vapor ambaye ni C3, if you condense that vapor, a liquid with 96 ethanol will be obtained. Yule vapor ambaye atakuwa na 96, tumefanya successive distillation and condensation, tumepata vapor ambaye na 96. So tukicondense tutapata liquid ambaye ana asilimia 96. Huu liquid tayari ni isotropic mixture. Kwa hata tukimboil tena na tena tutapata ile. Hence isotropic mixture will be collected as a distillate in the collector and the pure water remain in the distillation flask as a residue. Pure water remain in the distillation flask as a residue. Remember, I told you one thing about that graph kwamba anything which is in excess is the one which will be decreased. For example, to restart on the left hand side of the graph and then tukasema water it was in excess. If water it was in excess, then you want to decrease the percentage of water. Kwa tunapo decrease the percentage of water, tunavozidi kuondoa water, tunaongeza percentage of nini? Of nitric acid. So the amount of water in the solution obviously could decrease. We increase the percentage of nitric acid and hence finally the isotropic composition is attained. So therefore, it is impossible to get pure ethanol by distillating any mixture of ethanol and water containing less than 96 of ethanol. Less than 96 of ethanol. So remember, in our graph, we will have two cases. Because now we are going to discuss about the cases. We will have two cases. In the first case, we will see the solution containing less than 96 of ethanol. That means it is on the left-hand side of the graph. And in the second case, we shall see the solution containing greater than 96% of ethanol. What will be left as the residue and what will be the distillate. Kwa sababu gani? Tunavyokuwa tuna higher percentage of water, that means we need to decrease water so that to reach 96% of nini? Of ethanol. Lakini tunavyokuwa tuna higher percent of ethanol, we need to decrease ethanol. So in every case we shall see what will be the distillate and what will be the residue. What will be distillate and what will be the residue. Now let's discuss about the cases. Let's have the case 1. In case 1, what will happen when a solution containing less than 96 of ethanol is distilled? Now again remember, if it contains less than 96 of ethanol, manake percentage ya ethanol ndio ndogo. Percentage ya ethanol kama ni ndogo manake water ndio imezidi. Kwa hiyo tunahitaji tupunguze nini? Water. So on successive distillation and condensation, we will get pure water as residue. Kwa nini? Kwa sababu water ndio imezidi. Pure water as residue and the isotropic mixture as distillate. Pure water as residue and the isotropic mixture as distillate. So when a solution containing less than 96 of ethanol is distilled, the solution will boil in such a way that the vapor formed attains 96% of ethanol. That means isotropic mixture. Kwa nini tunasema the vapor formed? Kwa sababu huku kwetu kwenye positive deviation vapor au ile mixture inakuwa na boiling point ndogo. So isotropic mixture is more volatile kuliko pure liquids. In this case of positive deviation, isotropic mixture is more volatile as compared to the pure liquids. So this is done when more ethanol is distilled. This is done when more ethanol is distilled during successive distillation and condensation. Kwa hiyo tunavyokuwa tunafanya successive condensation and distillation, percentage ya water inakuwa inapungua, ya ethanol inaongezeka. Kwa percentage ya water inavyokuwa inapungua, ile water ina left kama residue. So isotropic mixture will be found in the collector. Tunavyosema collector manake vile tunapofanya fraction distillation kule ambako tuna collect ile vapor tuliyo condense tunaita collector. Lakini huku mwanzoni ambako ni distillation flask tunaita kama nini? Residue. So isotropic mixture will be found in the collector as a distillate containing 96 of ethanol and pure water remains in the distillation flask as a residue. Remains in the distillation flask as a residue. So we cannot get pure ethanol by fractional distillation. Kwenye case 1, we cannot get pure ethanol by fractional distillation. To get pure ethanol from isotropic mixture, a suitable drying agent like calcium oxide is introduced in the distillate so as to eliminate or to remove water which is only 4%. Water ambayo ni 4% hapo ni ndogo sana. Lakini sasa in case 2 tumedistillate solution ambayo contain more ethanol. Case 2 sasa, what will happen when the solution containing greater than 96 of ethanol is distilled? Now this solution is richer in ethanol. Kwa hiyo kilichozidi hapo ni nini? Ni ethanol. In successive condensation and distillation tunatakiwa tupunguze ethanol. Tupunguze ethanol tupate isotropic mixture. Maana tumestart on the right hand side ya graph ambayo tuko na discuss. So when the solution containing greater than 96 of ethanol is distilled, the solution will boil in such a way that the vapor formed is richer in water until ethanol is reduced to 96% in the solution. Kwa hiyo hapa kwa sababu tunakuwa tunapunguza ethanol. Kwa hiyo ethanol ndo itabaki kama nini? Kama residue. So on successive distillation and condensation finally gives isotropic mixture in the collector as a distillate and the residue in the distillation flask will be pure ethanol. Residue itakuwa pure ethanol. So in summary ni kwamba kile kilichozidi, if it is excess in ethanol will be residue, then isotropic mixture will be distillate in the collector. If it is excess in water will be residue. Water will be residue and then pure water will be residue and then isotropic mixture will be corrected in the collector. Kwa hiyo in summary tunasema kwamba in case 1, distilling a mixture containing less than 96 of ethanol. Kama contain less than 96 of ethanol, that means water ndio imezidi. Kama water imezidi, a distillate containing 96 of ethanol in collecting flask is obtained. Kwa distillate kwenye hii positive deviation, distillate atakuwa nani? Isotropic mixture. Lakini pure water is obtained in the boiling flask au distillation flask as residue. Unaona? Lakini in case 2 ambako tunakuwa tuna distill solution ambayo ina mixture of ethanol and water containing more than 96 of ethanol. More than 96 of ethanol, that means percentage of ethanol iko excess, imezidi ile isotropic mixture. Tumeanzia kwenye right hand side. So we will decrease the amount of ethanol. So pure ethanol will be found at the residue and then isotropic mixture will be corrected as the distillate. So distilling a mixture of ethanol and water containing more than 96 of ethanol, pure ethanol is obtained in the boiling flask as a residue. pure ethanol with the residue, and distillate containing 96% of ethanol is obtained in the correcting flask. Distillate itakuwa contain 96% of ethanol. Hiyo ni just explanation of example ambayo tulikuwa nayo. So for example, tuone mfano unaulizwaje, swali linaulizwaje. Study the diagram below and answer the questions that follow. In this diagram, we have liquid A and liquid B. We have liquid A and liquid B, and then from there we have a percentage composition here, 0, 20%, 40, 60, 96 and 100. So 96% is what we call as isotropic composition. This is because hii ndio pale ambapo isotropic mixture imekuwa formed 96%. Lakini from there we have isotropic point ambayo temperature pi Tc, tuna R which is the boiling point of liquid B and N which is the boiling point of liquid A. So from there sasa unaulizwa what does the points N, S, R, K on the graph represent. So for example, point N is the boiling point of liquid A. Then point R is the boiling point of liquid B. Point S is the isotropic mixture. TC is the isotropic point. Then point K is the isotropic composition. This is isotropic composition, isotropic mixture. Boiling point of liquid A, boiling point of liquid B. Unaona? Haya. B. What would you end up with a distillate at the end of series of distillation if you started with a solution sample of composition? Kwa hiyo kwa mfano umeanza na solution sample of composition, mole fraction X is equal to 65%. Manake kwa sababu kuimeanzia 0 kwenda 100, manake 65% itakuwa ni ya yule liquid B. Kwa 65% is somewhere here. Tumeanzia huko. What will you end up with? And then mole fraction X iwe sasa 98% ambayo iko huku right hand side. Again, remember, we are using the concept we have discussed. Kwamba from here, if we have excess of this liquid A, what will happen on successive distillation and condensation? On successive distillation and condensation, the excess of liquid A will remain as the residue, and on the distillate we will get the isotropic mixture. So kwa sababu liquid A ndio imezidi kwenye hii 65% ambayo tumeanzia hapa, kwa hiyo manake pure liquid A will be found at the residue in the distillation flask, and then isotropic mixture itakuwa collected pale. Lakini on the other hand, manake tukiwa tuna 90-80, pure liquid B will be collected at the residue, wakati kwenye distillate, kwenye collector tutakuwa tuna isotropic mixture. So kwenye collector na isotropic mixture, pure liquid B will remain at the residue. And then at the last question, what will be obtained as residue in 1 and 2? For example, in Roman 1, the residue will be pure liquid A, and in 2, the residue will be pure liquid B. Now in answering, first by answering about the letters, N is the boiling point of A or liquid A, R is the boiling point of liquid B, S is the isotropic mixture, TC is the isotropic point, and K is the isotropic composition. Now let's see the discussion about what will happen. So if we distillate, if we are doing distillation of a solution containing less than 96%, isotropic mixture containing 96% of B will be obtained as a distillate. So kwenye distillate zote tutapata isotropic mixture. Isotropic mixture containing 96% will be obtained as distillate. And Roman 2 isotropic mixture containing 96% of B will be obtained as distillate. Because our question asked that what would you end up with a distillate? What would you end up with a distillate at the end of series of distillation if you started with distillate? Lazima awe nani? Isotropic mixture. But our question C asks about the residues. After knowing the distillate, now what will be the residues? So in case of residues, tumeshasema kwamba if we are distillating a solution containing less than 96%, That means we have excess of A. So pure liquid A will be obtained as a residue in the distillation flask. While in case when we are distillating a solution containing greater than 96% of liquid B, that means it is excess of liquid B. So pure liquid B will be corrected as the residue in the distillation flask. Another question in this part, for example, you're asked to define the following terms: the boiling point, isotropic point, isotropic mixture, isotropic composition, and saturated vapor pressure. All of these we have already discussed. In question B, ethanol and water form an isotropic mixture which boils at 78.1 degrees centigrade, containing 96% of ethanol. The boiling point of pure water and ethanol are 178.4 degrees Celsius. The first question, draw temperature versus mole fraction diagram for ethanol and water solution. The second question, explain what will happen if a distillate aqua solution of less than 96 and concentrated aqua solution of greater than 96 of ethanol they are distilled. What will happen in all of these two conditions? And question Roman 3, why it is not possible to get 100% of pure ethanol by fraction distillation of a mixture of ethanol and water which contain less than 96% of ethanol. So kuhusu graph nilishaeleza, nilivyokuwa na chora hii graph nilishaeleza jinsi gani ya kuchora, lakini si mbaya kama nikarudia tena. Nilisema tu kwamba japo hapa nitaenda fast, so nilisema utakuwa na boiling point, then utakuwa na boiling point nyingine huku, boiling point. From there utakuwa na let's say boiling point ya water, boiling point ya ethanol. Water ni 100, ethanol tumepewa boiling point ya 78.4, so 78.4. Isotropic point ni 78.1, so itakuwa slightly lower 78.1, na tumepewa kwamba huku manake itakuwa ni ethanol, huku itakuwa ethanol, huku ni water, kwa sababu hizi boiling point ambazo nimeziweka, huku nimeweka ya water, huku nimeweka ya ethanol. Baada ya hapo tumepewa composition ya ethanol iwe 96, so unaweza kusema labda ni pale 96, and from here ambapo ni 96, so tutachora hii composition hapa iweze kumatch with this temperature. So graph yetu hapa itashuka hivi, and then graph yetu itaanzia huku, itashuka itafika mpaka pale. Huku graph yetu itaenda hivi mpaka pale, na hapo graph yetu itaenda hivi. So baada hapo tunachokisema tu tutalabel kwamba huku ni 0, hapa ni 96%, hapa ni 100%. Tukilabel tu hivi inatosha, kwa sababu ukisha label hivi inajulikana kwamba umelabel kitu gani. Huku 0, huku 100, kwa bila shaka hii ni ethanol. Isotropic composition ni hiyo hapo. Na draw a temperature versus mole fraction. Swali liko nasema draw a temperature versus mole fraction diagram for ethanol and water solution. Actually si tuyochora hii ni temperature composition, kwa sababu chini tumeandika composition. Composition ndio inaishia 100, mole fraction inaishia 1. Kwa hiyo baadhi ya vitu ambavyo natakiwa kujua hapa ni kuandika vapor phase, huku ni kuandika liquid phase. Mpaka hapo tu swali lako na kwa limeisha kama hivyo. Kwa unaweza kuona kwamba graph hatujachora, ila tumeenda tu kwenye kipengele kinachofuata huku. Kwa mfano kuna after having ethanol water mixture, how would you get higher? Okay, hapa wanakuuliza kuhusu jinsi gani ambavyo unaweza ka separate. Hizi definition tayari tunazifahamu, kwa sitazisoma tena hizi definition. Labda kama utataka tafuta tu notes either kwenye kipaji hapo au kwenye application yetu Play Store, tafuta tu hizi notes za solutions, notes za states of matter zimegawanyika kwenye makundi matatu. Kuna gases, kuna solutions pamoja na colligative properties. Kwa hiyo mimi nataka tuende moja kwa moja kwenye kujibu swali letu. So graph yetu ilikuwa inaonekana kama hivi. Hii ndio graph yetu ambayo ni jibu la ile swali. If you are looking at this graph, unaweza kuona kwamba haijatofautiana na hii. na composition hapa of isotropic mixture naona walituandikia ni 96. Sasa hii 95.5, I think it was the mistake of writing. So hapa ni 100, hapa ni 78.4, 78.1, boiling point, water ethanol 0. Unaona? Kwa hiyo again, tukidistillate solution ambayo ime contain more water, tapata pure water in the residue. And isotropic mixture is distillate. Tukidistillate solution ambayo ime contain more ethanol, pure ethanol as residue. Then distillate itakuwa ime contain isotropic mixture. Kwa hayo ndo maelezo ambayo yako hapa chini. Na I can't read everything, lakini kama umeshanielewa kule mwanzoni, I hope hata hapo umeshaelewa. Unaweza tu kazitafuta notes labda ukasoma mwenyewe kwa muda wako. Lakini kuna swali ambalo lilikuwa umeuliza, why hatuwezi kupata pure ethanol? Kwa sababu gani? Kwa sababu ya formation of isotropic mixture. Kwamba tukiboil baadaye tena kuform isotropic mixture, kisha form isotropic mixture, basi hapo hatuwezi tena kuseparate. Lakini methods za kupata pure ethanol ni kwa kutumia solvent extraction au powerful drying agents such as quicklime, ambayo tulishasema ni calcium oxide. This marks the end of our session, na kwenye kipindi kijacho tutadiscuss kuhusu behavior of non-ideal solutions. Non-ideal solution of negative deviation on distillation. Hizi ni non-ideal solution of positive deviation kwenye hiki kipindi. Kwa hiyo natumai utakuwa umeelewa non-ideal solution of positive deviation zinafanyaje, which one inakuwa distillate, which one inakuwa residue in situations kama hizo hapo. Na kwenye negative deviation the story will change somehow. Kwa hiyo just stay tuned. Make sure you are viewing my next session which discuss about the negative deviation. For any question you can comment, you can join my Telegram group, you can like my Facebook page, you can ask me or find me in different ways. Thank you everybody, and let me wish you nice studies.